Hello and welcome to the beSTORM training session. Today we're going to cover beSTORM, the fuzzing framework platform provided to you by Beyond Security, which is used for black box testing. So first, black box testing. What is it and what is it about? Black box testing is a method of testing devices when we have no information about them. Unlike vulnerability scanning, where we know what the device is using, what services are open, we know what CVEs could be there potentially, etc. Or unlike static analysis where we have exposure to the code, so we see the actual code and then start do the testing. Here in black box testing, we have no information about the device except for the protocol it's using, the IP, and the port. And this is really important because fuzzing is the closest test that works to the methods that attackers will use. So attacker doesn't have exposure to your code. He doesn't necessarily know what you're using unless you start doing more sophisticated tests and discover what is the banner received from the Apache server, or what is the Windows OS type, or if it's a Windows server, and then he can start do some testing for that specific thing. But attackers would normally find like an open IP in Shodan, for example, and a port and some basic information saying like this is a Rockwell server, a Rockwell OT device, and then you will start do the testing. And the testing you will do things like brute force, denial of service, trying to get remote code execution, trying to crash the protection means in order to bypass the login, and so on. So beSTORM tries to mimic those actions, and trying to provide you with the same, discovering of zero-day vulnerabilities that were not exposed before. It's not going after CVEs and against spanners, or even doing it in a behavioral manner like other tools do. It's actually going by learning the protocol, starting to send input and see which point there is a loophole, which point there is a security flaw. And those vulnerabilities normally are 0 days, they are not documented, and they will be discovered in the verification phase, of the software, when I try to verify the software or the device before I send it to the customers. So let's look at the beSTORM package and understand what we've got over here. So beSTORM comes with 2 routers. Those will be used to convert the IP packet sent by beSTORM over to BT, for example, or USB. So if I want to connect to a Bluetooth device, I have 2 profiles here, A2DP and N3 profile. And now I can connect my Jabra Evolve to this BT router, which the BT router will receive over UDP. It will receive the packets, the injection, and then it will inject it to the Jabra Evolve. So for example, you can see that we have established connection with my Jabra headset. So I'm going to stop it over here. Now, this is just the regular Bluetooth. We also have Bluetooth Low Energy that covers several protocols like RFCOM, ATT, GAT, and so on. We have the USB router. We work on a similar concept, so you'd have an injection engine and the monitoring host. And what's nice about the BT router, the USB router, that it's also monitor like your communication with the device. The USB router will be used mostly when we're trying to fuzz like a peripheral device, when we try to fuzz a mouse or a USB storage and so on. If we wish to fuzz USB host, for example, the USB host on your car, then we might be using something called Easy USB, which is a dongle that we can use. So we have several dongles cables that goes with beSTORM, and we will discuss them later on. Within beSTORM, we also have monitors. So before we go into the monitors, I will show you why do we even need monitors within the topology map over here. So beSTORM will send the malform inputs. It will send like the fuzzing data, and that will be sent to the DUT, the device under test or software under test. The DUT will have a bi-directional communication to the monitoring program. So it could be a program, but it could also be a script or the built-in like a service in beSTORM. The monitor will communicate back to the client and sending it like a no operation command as long as the DUT is up and running. Once the DUT has crashed, the monitor will send to beSTORM like a command saying the DUT crashed. And so beSTORM will send the packet that he just sent to the DUT. So we will understand what actually caused this DUT to crash. where in my protocol, where in my module this DUT has crashed, like which place on my device I should fix. Now it goes by generation. As I said, the beSTORM client learns, like the RFC learns the protocol on which this device communicates. It learns the data structure, and then it learns how to generate, like where are the buffers, where can I send malinformed informed inputs, where can I send like fuzzed data. So the types could be like 60 based on 64 encoding, or just normal strings. Like you can see here, the A becomes the dual, becomes triple, becomes 4 times A, and so on, and it's endless. And then we also have the integers, so we're gonna send like 0 and 1, 2, 4 million, 8 million, and so on. And it's really much depends on the types of buffer in the protocol. Let's say if in HTTP we would expect a command saying keep alive 1 or keep alive 0. What happens if I send keep alive 4 millions? How would the DUT react? Would it crash? Would it lose the protection of it? What will happen? Those are the type of buffer that you can normally use, and what's nice about it that you can edit it. So you can remove any buffer type that you don't want to use. If you don't want to use repeated A, you say, okay, in my DUT, I know that the %25N is not accepted by any means, so I can just remove it. And I can also add my own buffers. Like let's say I want to add buffers such as repeated space, for example. And then we have the monitoring function. As I said earlier, the client can monitor either UDP, TCP, and ARP. And also there is the beSTORM package. There is a monitor in the beSTORM package that can be used for monitoring Windows services and processes. So now we're gonna go into the monitor package I was speaking of earlier. So I'm gonna start up the beSTORM monitor, and now I see in my calculator, I can attach it to the host. So I can basically start to monitor it. Once someone turn it off, it will come back up again. So see the calculator X, you can exit it, and you can see that the running process has failed. So basically what the beSTORM will do is refresh constantly, like monitor the device constantly. So it will refresh it all the time. And whenever this device fails, it will restart it. So let's say I have the simple web server here. Now I'm gonna look for that in the monitoring. So give me just, let's see, simple web server. Now this is gonna be attached and persistently monitored. Now when I turn it off, it should come back again. The beSTORM monitor recreate the operation. So when it will be fuzzed by the beSTORM client and crash, it will also get back again, like the process will be restarting. So that's give me the ability to do a very, very extensive fuzzing, like in more than a day or 2 or even 3, because whenever the DUT crash, I will be notified, and beSTORM monitor will bring it back again. So let's see, touch it, because I don't want to run the monitor in this case. This is the built-in monitor, of course. We also have the samples I was speaking of earlier, like the Bluetooth monitor over here. So I'm going to edit it with Notepad. That's a Python script, so I can put in the IP, the port that I'm fuzzing, the MAC address of that Bluetooth, Bluetooth device, and so on. So I can decide on what, like, if commands I want to do, what I want the logger to look for, etc. When I want the logger to announce that the DUT crashed, and so on. I can build up. It's beSTORM. It's not a plug and play product. It's a framework. So I can build up the type of you can see other monitors here for SSH. So I can build up the type of monitor that I'm looking for, and I can customize them based on my actual product. Let's click on X over here. We have a lot of types of monitors in here. Now we're going to open up the beSTORM client. Now I'm going to get an error message. As you can see, the error message is for the Sentinel key that is missing. So I'm now going to insert the Sentinel key. Basically, beSTORM comes with the dongle, and that's the licensing. So it could be either a floating license by using your MAC address, or by using the Sentinel key. Without the Sentinel key, beSTORM will not work. When you look at beSTORM, you can load up historical projects. You can create a new project. and open up the user guide and download it so you can learn a little bit more about beSTORM. We also gonna start up a beSTORM project now, so and let's load it up. So there are two options. There's an option for a simple or advanced project. So advanced projects will also let me to tweak a little bit the monitoring settings and set up settings such as treat network connectivity and exception, etc. We're gonna go with a simple this time. We can also do a port scan prior to the fuzzing. So we will learn what modules are relevant. So I'm going to put the IP over here and click on port scan. And then you would see the list here with the module name that will give me all the relevant modules that I can test. I'm going to go back and we're going to go with a simple project this time. So now we have to choose either a predefined module or to import a module or build one. We can build one by, like, let's say if we want to look into the network module, we can build one by learning. So beSTORM can be the man in the middle, or we can use an HTTP proxy, or we can even use a sniffer. We can attach a sniffer and learn the communication to that IP. And so that will help us build up a module relevant to our specific software that is on this IP and so on. Now we also have other types of buildings, module builders, like the file module. So I can go ahead and import a file, for example, ICS, and I'm going to generate it. And so you can see that beSTORM performs the code coverage and learn that specific file, and later will provide me with the fields for the testing, and so I can start testing based on what I found on the file. So for example, I'm going to stop over here and just choose them all, length value reserve, and I'm going to click on use. I need to save it. So new folder, click on OK, next. And when I'm going to start beSTORM, you would see that it's a Autolearn module. So an Autolearn module works a little bit different than regular modules. You can see that it has 65 million combinations covered. And here you can see the types of fields there are in this module, etc. You can see here the settings. So if you're already looking at beSTORM, we can do multi-threading. So create attacks from several threads, like, checking for distributed attacks over here. We can do advanced settings. So decide on how many combination we want to test per buffer. Base 2 plus minus 1, that's the default. Base 10 is like really minimal. It's 68 combinations per buffer. We have serial, which is a really extensive one. It's a very long time to complete, but that's really check every potential like tweak to the buffers. We also have the ability to set the saturation rate and to edit the module environment. So the module environments are used when I'm looking to fuzz like an IP and this require a password to log in. There's some basic commands that the DOT is looking for before I start fuzzing and so on. We have the ability to edit the buffer type, so I can delete this one, can add something else. It's really much up to me. Close. And then we have the ability to look at behavior settings. So the behavior settings would be looking for sending me an SMTP notification. So sending me an email whenever the test found an exception, or when the test ended, or when there was an error in the DOT or in beSTORM itself, and so on. So I don't need to sit here and wait for the test to complete. I can just let it run and notify me when needed. Monitor settings. So here I can tweak the way I'm going to monitor the scanning, like if I want to run ARP echo, ICMP echo, or TCP echo, for example. If I want to set up an external monitor, if I want to report connectivity issues as an exception. So in case there is an issue with the network card, I would like to report connectivity issues as an exception. So I can also set up the minion to start. So the minion is a way to run the fuzzing as from somewhere else. Let's say I'm going to install a minion on one device and I'm going to install beSTORM client on another. So beSTORM client will send packets to the minion and the minion will transmit them over to the DUT. In this case, again, this is like the monitor settings that I can apply. And actually the monitor types are normally applied also when setting up the module. So when setting up the project, you're going to go ahead and click on new project. This time we're going with simple. I click yes. And now we're going to cover a little bit of after we've covered file module, we also have a API. So it goes against the same process. We're going to click on the desktop. We have Slack Open API. Click on process. Those are all the fields for the testing. So once I click generate, I can just test my API basically. We also have the ability to build CAN module using pcan or CANbuster and so on. So here we need to open a DBC file. That's a different type of file. And we also have the ability to import custom modules that we have created earlier. Now we're going to go into the predefined modules. So we have the basic package, which includes DHCP, HTTP, IEC, like very, very basic Modbus, SMTP, and so on. Then afterwards, we have the TCP clients, which we're looking into now. Right below TCP clients, we have a full package of UDP clients, like BVLC, for example. And you got the L2 cap and so on, OBEX, Radius protocols. So those are the modules that will use UDP, 6log, of course, USB, mass storage, and so on. Server side, so we also do testing for like server side. For example, MMS will be tested from here, while Goose, for example, will be tested from the TCP client side. Low-level network, we also have Goose in here for the low-level network. We have Wi-Fi, for example, IPv4, IPv6, and then we have file fuzzing. File fuzzing is actually interesting because it's not a direct fuzzing from the client to the DUT. It's a generation of malinformed files. Like instead of sending like wrong packets or packets that can cause the DUT to crash, we're going to generate broken files, and we want to see how the software handles those files. So for example, if you have a DLP and this DLP is used to scan for Excel and Word documents, what happens if it's going to scan for like the files that were generated by beSTORM that are not legit files? They're not malware, on the other end, but they are not normally digested. So we want to see how does the DLP handle those. You have a lot of types of file fuzzing over here. Then you have also EDSA, so for EDSA certification, lab certification. Of course, beSTORM is certified by EDSA. Bluetooth and Bluetooth LE, as I described earlier, so you can see iBeacon, L2 cap, MCAP, OBEX, RFCOM, serial, and followed by serial is automotive. So we have CAN bus, OBD2, UDS. Today we're going to cover BVLC. So we're going to cover BVLC. It's a UDP client. We're going to set up the BACnet server. BACnet is a software used for building management back in the past. I think nowadays it's less in use. So we're going to go against 192.168.190, I believe, .1. Let's see. Yeah, that's the one. I'm going to click on next. Next again, those are the environment variables. Again, I can change them. Most importantly, that if my BACnet server is on a remote port 47808, then that should be the port value over here. Click on next. Decide on the monitoring we want to use. So in this case, the DUT responds to UDP echo. So that's the type of monitor I will be using. And next again, click on finish. So now we will see the monitoring status is running. beSTORM sent UDP packets and receive the response the required. We're going to click on start. Now you can see the fuzzing started, and you can see the types of packets we sent to the DUT, types of packets we sent to the BACnet server. So I could have waited for beSTORM to do the fuzzing, but fuzzing, you know, is an extensive process and it takes time. And what I want here is just to show you what we can do with beSTORM. So what I did, I just killed um, the BVLC module. But basically, you can see here that beSTORM found an exception. I can export that exception, and with that exported exception, I can rerun the script and check the crashing of that BVLC, you know, UDP client or that web server and so on. So in this case, we will skip that. We can also generate a report. So beSTORM also check for like non-CVEs and scene floating, synchronizing floating, non-web credentials and so on. But this is more, you know, when I already covered the fuzzing section of it, I will look for the known vulnerabilities. You can also click on show detected vulnerabilities, see all the suspected vulnerabilities that I found. So in a fuzzing process, if I find 4, 6, 10 vulnerabilities, I can go in between them, you know, by clicking on the forward button. And furthermore, I can look into the ability to generate a report in PDF or HTML. So there you go, you can see my report. The report will cover all the feeds that I've tested, um, the environment variables that I've used, the buffers that I have been testing, etc. And then you can see the exception that was caught. So for each exception, you can also export it in a Perl script. And then you can see here the process that I've done. So what is the status, if it's been done or not, or if it's in progress. So here it's only in progress because I haven't really run much of the fuzzing. And with that being said, I can also, after looking at the report, I can also bring back the backnet server, and you would see that the monitor status changed to running, and I'm going to click resume and return the testing. So another vulnerability has been detected, and here you can see the action that beSTORM is doing to the backnet server. So you can see the backnet server receiving some commands and is discarding them. So it doesn't accept them. You see, it's rejecting those commands. So we kind of pick up on the testing now. And by the time we do that, I would like to show you like a sample of XML files, because you can actually import your own XML files into beSTORM as a module. So let's see if I have here the CAN interface. You can see that's the way beSTORM communicates. So for the test, you will have to give the M, that's the name of the module, the P is the type of the protocol, SC is again the name, and then you can see like each EV is environment variables, okay, and S is a sentence, and several sentences making into like several buffer would make into a sentence, several sentence will make into a sentence enumerator that will choose, you know, what to run. So that's the way beSTORM running. It's basically you can take the XML and understand the entire protocol and then run the fuzzing on it, so you can build it yourself, tweak it based on your specific DUT. Now we are done with it. We see another exception was caught. So we can see that the places on my beSTORM router, that in my beSTORM client, like the places on the module where it's been caught. And then we're going to click on X over here, and I can, as you can see, the backnet server is down. Basically, beSTORM crashed it, which means that it succeeded in its mission. And now I can generate the report again in a PDF format. And then there you go. We can see that we've done more testing. We have more exceptions that were caught. Those are the feeds that beSTORM tried. So a lot of A's, as you can see here, a lot of A's, in fact. And then you can see what has been done. So we were in progress of the NPDU, but we already done the original broadcast NPDU, the backnet NPDU. We've done many fields already in the protocol. And this is not yet enough, you know, because of course in fuzzing scenarios, you would like to configure beSTORM with a monitor that bring up the device again and again, and you would like to configure the settings to have the behavioral settings as I configured over here. So you would get anytime that the test finds like a violation or a vulnerability, it will be exported to you, send it to you over email. We also, as I said, we also have the type of you see the Python script that we have exported. So let's open this one, edit with Notepad. Now you can see what is the command that beSTORM sent, what is the attack vector, and on which host and port, at what given time. And when you take that script and run it again in Python, when the BVLC UDP client is running, then you can crash it again. So this is like the proof of beSTORM finding the vulnerability, and you can replay it as much as you want. Also, if you want to go back in the testing, you have the bookmark, so you can go several seconds backward, a minute backward. I want to see what happened like several seconds ago. So there you go. I'm going to go back, and now I can load up again the attack vector. So that's a good example. I don't want to save the current settings, and I think I'm pretty much done here. So we're gonna do another short example of another thing that beSTORM covers. So we did cover the Open API, we covered the file, we covered fuzzing on BVLC. Now we're gonna run it quickly. File fuzzing. So I'm gonna set up beSTORM again. There you go. I'm gonna click on. It did something wrong here, so just a sec. So we're gonna click on next again. And we're gonna do file fuzzing. So this time we're gonna save Excel files. I'm going to save it in my desktop, make a new folder, beSTORM Excel. Now, just for you to see the capabilities of beSTORM, how many files will it generate? I'm going to need to create path, and there you go. So if I'm going to open up my file folder, I would see here that beSTORM starts to create directories, and within each directory, there's going to be a lot of Excel files. And this is later can be used for me in a script, so I can run it folder by folder, for example, and see how the DUT reacts to it. That was me giving you the first beSTORM training session. So stay tuned for more. Thank you.